All right, so let's just begin with a quick chat about where we are and where we're headed. So if we're following along our checklist, you can see it's a real squeeze, this unit, and it's always a bit tricky getting it in before the end of the term. In previous years, we've tried to get the test in, but like this year, we've had too many interruptions. So us and the other teachers, we're doing it next term. So today we're going to make our way through 2H. A little bit like 2G in that there's some complex elements of it where you need to develop an equation, but it tends to be not as challenging. So I'll just talk about 2G with optimization. In your test there will be one question on it, but it is pretty easy. It's only worth about 3 marks all up, that one question. There will be a question on optimization that we're going to do today, but we can worry about that when we start getting into the revision. So that leaves us 2H, then we're finished quadratics. And most of the unit that we are doing is quadratics, right? That leaves us week 11, where we start chapter 4, which is on polynomials. And we don't do all the exercises, we just do the ones that are relevant. So for instance, on Tuesday, we're going to go through exercise 4A.2. We might talk a bit about 4A1. On Thursday, we'll go through 4C. Both of these are relatively fun exercises. They just require a bit of expansion, and it's just a nice, beautiful, methodical process to arrive at a solution. And then 4E, we're looking at graphs of cubics and quartics, 4E and F, and that just follows straight on from quadratics, so we should find that okay as well. Now, I would also like to hand out the folio task in here. Just because if I hand it out before holidays, the more time you have to work on it, ideally, the better it's going to be. So during the holidays, you can spend some time on your folio, but definitely I will hand out some easy stuff to just keep your mind, keep these things fresh in your mind, keep quadratics and polynomials fresh in your mind. When we come back, we'll do a really thorough recap, like we did that lesson leading up to functions and relations. Couple of revision lessons, formative tests, sit down test conditions kind of thing, another revision, and then we test Thursday. We have lessons on Thursday. Thursday of week 2. Very good. So today, 2H. So let's open up to there. Optimisation. So what have I written? First, develop relevant equation, find the optimal solution. Let's talk about what that means, optimal. If we're finding the optimal solution, it means the best case. It means the most economical, the one that's going to either save the most amount of money or have the most amount of area for the ducks to run around in, or use the least amount. It's like the best solution to the problem, optimization. So here we've got the profit in manufacturing, X kettles per day, is given by this equation. P of X is equal to minus 3x squared plus 564x, take 1200. Okay, this is the profit when manufacturing X kettles. Now, let's all sketch this function. Okay, so pull your graph out. We're going to have a sketch of it. We're going to talk about how we can arrive at an optimal solution just using our calculator. So in graph mode, input that in. And I'll talk about our V window a bit. 3 squared plus 564x, take 1200. Okay, what's the y-intercept of this function? Can anyone tell me?
Minus 1200.
Minus 1200. Y-intercept when x is 0, minus 1200. So that means for our V window, we should probably go from like minus 1200 to 2,500 for y. Alright, so when we're talking about our V window, X min, X max, Y min, Y max. Okay, so our Y min, the y-intercept is 1200, so it needs to be at least minus 1250. That's going to allow us to see the y-intercept. And then the y max, I'm not really sure, I'm just having a bit of a guess here. Let's just say it's a bit larger, 2,500. Might need to change it, all right? When we graph it, we can make an informed decision about what it needs to be. Now for x, our x min is going to be 0, because what's on the x-axis? In the context of this problem, it is the number of kettles made. We're not going to make a negative amount of kettles. So our x min is 0, and x max is just a bit of guesswork as well. Let's just set it as 100 for now. So let's stick with them and see what it looks like. All right, we might need to adjust accordingly. Minus 3x squared plus 564 x, take 1200. I haven't set my V window like you guys, so I've got 0 to 100, and from minus 1200 to 2500. All right, so looking at it, okay, if your graph looks like mine, this is what we're seeing. All right, can't see anything really, doesn't look like a quadratic. So here's another option we have, and that is, see where it says F2 is zoom? Let's press F2 and then press auto. All right, and that should zoom it out a bit. And so now that I've pressed zoom auto, it's starting to look like this. All right, so I can see that component of it. That's pretty good. I can almost see the whole quadratic. I just need to double x basically. I'm going to anticipate it's going to come back down because it's a quadratic. So we'll go back into V window, and whatever our x max is, we'll just double it. Double it or triple it or something like that. And then you've got a beautiful quadratic there. So, let's go on like this. And we were way off with our y max. It was 25,000, I think. Okay, so zoom auto can be useful, but it won't always show you the whole graph. It's just going to show you something. So that's a feature we can use. All right, so we just spent about 5 minutes building up, developing this graph. Let's talk about what this graph shows you. Read the question. The profit in manufacturing X kettles per day. Here we have number of kettles. And what's on the y-axis? This is the P of X function. Here we have profit. Now, if you're making kettles, you want to make the most money possible. So that is going to be the optimal solution, right? The maximum, okay? So one way we can do that is G-solve max, right? G-solve F5, the max. And if I do that, I've got
94.
X is 94, and I've got the profit, $25,000.
It's an expensive kettle.
Yeah, oh, they're pristine kettles, these ones. They're gourmet. So, now, some people might be frowning. Why wouldn't it just be the more kettles you make, the more profit you're going to make? Can anyone think of a reason why, if you keep making kettles, your profit might start to deteriorate?
Because you have to
Production costs.
Production costs, so employing people, is that what you said, Noah?
I just said too much supply.
Too much supply, yeah. So I can think of two reasons. Firstly, you'd have to pay your employees overtime, and if they're working longer than they should be, they get paid double time, time and a half, so forth. And the third thing is equipment that is used to manufacture things starts to deteriorate and decay. And so, you need to maintain your equipment, otherwise it's going to cost you too much. You have to replace the whole thing. And so, yeah, you might say it's ridiculous. Just make more kettles, you make more money. Now, there's an optimal solution, and we've G-solved it. Okay, so that's how we can use our calculator to inform our decision. All of these, you can graph and G-solve the max. How about using an algebraic process? Well, one thing we should remember from quadratics is that the max or the minimum, what we call the vertex, the x-coordinate of the vertex is minus b on 2a. Minus b on 2a. That is always the x-coordinate of the vertex for a quadratic. And if we consider our quadratic here, we've got a is minus 3, b is 564, and c is minus 1200. And so if we put that into this formula here, we're going to have minus 564 divided by 2 times minus 3. I'll just do that in my head quickly. 94. All right, x is 94. All right, so we know that from our calculator, that's the local max. But the point I'm trying to make is this formula tells you the coordinates of the optimal solution for a quadratic. X is minus b on 2a. So we've got x is 94. 94 kettles is the optimal solution. Find the number of kettles to maximize profit and the profit. Okay, so Noah, algebraic approach. Well, we've got 94 kettles. This is the profit with regards to kettles. So then we're going to find P of 94. We're going to say, when I put the number 94 into this function, all right, so it's going to be minus 3 times 94 squared plus 564 times 94. Take 1200, and I'll just do that quickly in my head, and you get $25,308. All right?
You're a genius.
Genius. Okay? So let's make a link, right? Okay? So you saw here, if I G-solve the max, I got 94, 25,308. I'm saying, how do we do it algebraically? We use the x-coordinate of the vertex, minus b on 2a. We've got our x value. We want to know the corresponding y value, and we put that into our function, because that's going to tell us the y value, given that's the x value. Very good. All right, so can I clear the board a bit? All right, any questions at this stage? So on to number 2. We've got a chicken cage is erected against a wall. All right, so this is going to be pretty similar to our optimization. Here's the wall, and we've got a chicken cage. It's a rectangular chicken cage, it should say that. What is the optimal solution that generates the most area? So we've got 30 meters of fencing in total, all right? So this fence plus this one needs to equal 30. All right, so we need to set one of our sides to x. It doesn't really matter which one we do. I'm inclined to do this one because then they're both x. They're both the same. And then the length of this side is going to be 30 take away 2x. All right, and the way I've arrived at that is if we add up all of the sides together, x plus 30 take 2x plus x, x plus 30 take 2x plus x. Look at this, x plus x is 2x, take away 2x, that part cancels, we're left with 30 meters of fencing. Okay, so then we're asked, let's answer the question, what is the optimal shape that generates the most area? Well, the area, okay, the area with regards to x of this rectangle is x multiplied by 30 take 2x. Length times width, x times 30 take 2x. All right, that's 30x take 2x squared. We have an area function. It's a quadratic. Okay, what's A, what's B, what's C? That should say x, sorry. 30x take 2x squared. Is A 30? No. A is the coefficient of the x squared term. Okay, here's x squared. So our A value is minus 2. B is positive 30. How about C? 0. All right. The y-intercept of this quadratic equation is 0. So here's our A and B. We use minus B on 2A. That gives us the x-coordinate of the optimal solution. So we're going to have minus 30 on 2 times minus 2. So if this distance is 7.5, then this one here is going to be 30 take away 2 times 7.5, 30 take away 15. This distance here is going to be 30. So we've got 7.5, 7, 15. 7.5, 7.5 and 15. That's going to give us the optimal solution. I'll just talk about that quickly. So we know this is 7.5. This one is going to be 30, take away 2x. But what is x? 7.5. 30 take away 2 times 7.5. 30 take away 15 equals 15. So the best outcome, the one that has the most area, is 7.5 by 15. Alright, when x is 7.5 and the other side is 15. Now, all that is to say is, like, what's going on here? When we have this rectangle, there are lots of possible ways that it could be. And like if we've done normal maths, there's a great assignment we do in year 9 where we investigate areas of rectangles. And so you'd start with one like this where you have, it's 1 metre wide and then it's going to be 28 metres long. All right, so you've got 1 plus 1 plus 28, that's 30 metres. All right, what would be the area of this rectangle? 28 metres squared. Okay? And then we go, okay, how about one like this? If this is 2 and this is 2 and this is going to be 2, 4, 26. All right, adds up. Still we've got 30 metres of fencing. What's the area here? 2 times 26, 52. Look how much larger it is. Okay, and so all we're doing is changing these until we get the optimal shape, the one that provides us with the most area. And that's what we've arrived at here using this process. Okay, minus B on 2. All right, everyone feeling okay about it so far? All right, I'm going to stop there because I think it'd be good to try it out. There is one more question, but I don't want to overwhelm you going into this question just yet. Let's do that towards the end of the lesson. Let's stop for now and have a go at some of the questions using minus B on 2A. All right, so question 3 from our notes, even if you're not finished or up to question 5, follow along here. So I'm going to say this question has popped up a fair bit in previous tests. There's a high chance of it popping up in this test. Not this one exactly, but of a similar style. It's a good way of asking an optimization question. So we've got 1,200 metres of fencing and we're going to make 6 identical pens for our pet pigs to run around in. So you can see we've got 6 pens. And I've defined the dimensions of each pen. We'll do this for you in the diagram. We'll give you X and we'll give you Y. Okay, so each pen is identical in shape and size. A says, explain why 12 lots of X plus 7 lots of Y equals 1,200. So the answer, this is 1 mark. We're just going to say, well, there are 7 lots of Y. If we go 1, 2, 3, 4, 5, 6, 7 lots of Y plus 12 lots of X has to add up to 1,200 metres of fencing. So that's the answer to part A. Okay, so 1 mark there just for saying, well, all up in the diagram here, we need 12 lots of that length and 7 lots of this length in order to make the structure that we've got there. Okay, part B says, here's exactly what I was talking about. Show that the area is this. Show that the area is this. So even if you can't get the answer to part B, you can still go ahead and answer part C using part B, right? Show that the area is this. We want to know the area of each pen, right? Well, the area of the pen there is the length times the width, which is going to be X times by Y. X times by Y. The problem here is we have 2 variables. We've got X and we've got Y. So we want to express it in terms of 1 variable. And so we've got here, we've got 12X plus 7Y is 1,200. So we need to use this somehow. In fact, I can rearrange this to get Y by itself. All right, so first I'm going to subtract 12X from both sides. And then I'm going to divide both sides by 7. And what we'd have is 1200 on 7, take 12 on 7x. Alright, or we can keep it like this, okay? Either of these is fine. I'm just trying to think what's the best way to arrive at the answer. Let's keep it like this, okay? So then right, we have the area is equal to x times y. And what is y? Y is this thing here. So we're going to take that and bring it up here. So then our area is x multiplied by 1200, take 12x on 7. Okay, and we're getting pretty close to what they have there. And whenever we have like a fraction, like if I have a on 2, it's equal to half of a. If I had x on 5, it's equal to a fifth of a. Here, I have this whole thing on top of 7. So I can pull that 1 on 7 out the front, right? I can express it like this. Okay? And that is the area of one pen, right? One pen is x times y. And so the reason they've got a 6 there, which I think we should get rid of, but the reason they've got a 6 there is because there's 6 pens. So the total area is going to be the 6 pens multiplied by the area of each pen. So that's how we arrive at. This would be worth 2 marks. And what you're doing is you're starting with this, you rearrange to get y by itself, and then you perform the substitution and process until you have the area formula. Okay, so that's 2 marks there to arrive at the area formula. Look at the third mark. Find the optimal solution. Okay, now this is, what are we doing? We're doing optimization. When does the optimal solution occur? At minus b on 2a. X is minus b on 2a. So if we consider this function, at the moment it is a quadratic, but it's not expressed in a form that's useful to us. We need to expand this. All right, we need to expand it. And so what we're going to have is we're going to have x at the top and 7 at the bottom. 1200x and 7. And then the same with this one. It's going to be 12x squared at the top and 7 at the bottom. Okay, and I'm just showing you what's that equal to. 1200 on 7x. Take 12 on 7x squared. All right. So now it's a quadratic, and we can see the a value, we can see the b value, right? Write them down. A is minus 12 on 7. B is 1200 on 7. Okay, so it's a little bit more confusing than the nice pretty ones with just straight numbers. We've got fractions, but nonetheless the same principle applies. The optimal solution is minus b on 2a. So that's going to be minus 1200 on 7 on top of 2 times minus 12 on 7. So at this stage you can put that in your calculator, right? You can put that in your calculator to determine what's the value of x that provides the optimal solution. I'll process it a little bit for you. So, what's the 2 here, that's going to the top of the fraction. We've got negative at the top, negative at the bottom, so we can get rid of those. So we've got 1200 on 7 on 24 on 7. And when we've got 2 fractions divided by one another, remember A on B on C on D is AD on BC. So 1200 times 7 on 7 times 24. So look, I've said you could have put that in your calculator. I'm just processing it manually. 7 at the top, 7 at the bottom cancels. 1200 divided by 24. 50. 50. Okay, so what's the important part? Look, finding the equation is hard. That's a tricky to show that the equation is this. But then once you've got the equation, we're doing minus b on 2a. That's what we've done there. We put that in your calculator. It'll evaluate to 50. So we've got x is 50, but we need to answer the question. The question is, what is the size of each pen? Well, x is 50, but that doesn't tell you what y is. Okay, so in order to answer the question, we need to know the value of y. Well, look at this equation. Y equals 1200 on 7. Take 12 on 7 times 50. So we can evaluate that using our calculator. When x is 50, y is alright. I'll crunch that. Unless someone needs me. Can't do that one in my head.
600 on 7.
607?
600 on 7.
Thank you. 607?
600 on 7.
On 7. 600 on 7. So what's that? 85. I'll just say it's there about 85.7. Okay, so the dimensions of each pen then is 50 by 85.7. So this is really a sort of a 3-mark question. You get 2 marks for doing that and getting the x value, and you get the final mark for determining the y value and answering it. Okay, so this is a tricky problem. Let's just do a big recap of what we did. First, explain why 7 lots of y plus 12 lots of x is 1200. Okay, done. In the next part, show that the area is this equation. So they give you the equation. Even if you can't show it, you can still go ahead and answer this part, right? Minus b and 2a. How do we show that the area? Well, the area of this pen, it's x times y. But that's not helpful because we need a single expression for y. We use that equation. That's why they gave it to us. We rearrange it, get y by itself, sub in up here, process that, there we go, there's our answer. Okay, then we did the minus b on 2a, processed it, x is 50. What's the corresponding y value? Put it into the y equation. Alright, so quite tricky. So there's a good, I think question 5 and 6. There's 3 questions that are similar to this, of a similar style. So there's lots of practice. Any questions about it?